right, so scatter plots. Scatter plots are a type of graph that relates two types of data. Okay? Scatter plots are ones where you have an x and a y axis and you have points on it somewhere scattered about. Okay? Scatter plots. You guys have done these, I'm pretty sure. There are several types of what's called correlation. We have positive correlation, negative correlation, and no correlation. All I mean by that is, let's look at this positive correlation. A positive correlation means both sets of data are increasing together. Okay? An example might be you do every single homework assignment, could be one of the variables, and the other variable would be your grade goes up. So both of them rise together. Okay? And a positive correlation looks like this. Your scatter plot would look something like this. Okay, they would kind of go up together. A negative correlation, one set of data decreases as the other increases. The fewer the students that do the homework, the higher my frustration level goes. Okay, so that would be like that. Okay, and then no correlation is like the first one I drew. There's no rhyme or reason to it. There's no pattern to it. You can't really draw any type of line through it. Whereas the positive negative correlation, we can draw what's called a line of best fit. All right, a line of best fit is where we can take a line, okay, and cover over the data and make it fit. Or use your pencil. Is that what you're trying to say? Use your pencil, line it up. So this would be a line of best fit, which is also known as a trend line. And that's what we're going to be working with today. Is we're going to make a scatter plot. We're going to draw the line of best fit on it, and then we're going to find the equation of that line. All right? We're going to find the equation of the line, which we did already. The only new part will be really drawing the scatter plot and the line, because we've been writing equations of lines since we got back from Christmas, and even before that. So let's look at our first example here. It's the only one we're going to do today. There's an example on the back, but we're only going to have time to do this one example. It says to make a scatter plot to represent the data, draw a trend line, and write an equation for the trend line. And then use the equation to predict the time needed to travel 32 miles. We're not going to worry about this last question until the end, okay? So we'll come back to that. Right now, what we're going to be doing is we're going to be using this data, speed of a bicycle trip, or speed on a bicycle trip. We're going to put that data onto our graph and then plot it. And I know you guys in science have been doing this where you've been making graphs, right? No. Yes, you have. And you have to scale them, you know, you have to figure out what your scale is going to be. Yeah. I'll go tell your science teachers that and see what they say. All right. So, we have to figure out which goes on our x-axis, which goes on our y-axis. We have time and we have miles. Which one goes on the x-axis? Time always goes on the x-axis, yeah. So time is our independent variable. Miles is our dependent, I'm sorry. So we have to figure out how we want to scale this. Time is our x-axis. This is our y-axis. On time, we have the smallest number to be 27, the biggest number to be 107. So we need to fit all of those numbers on our graph. So we need to figure out how we want to scale this. So what do you think is the best way to scale the numbers between 27 and 107? Any ideas? We're going to go by ones? No. We'll run out of room, won't we? We don't have that many blocks. 5 is pretty good. That's what we've been doing all day. 10 is too much. 1 is not enough. 5 works out really well. So I'm going to label, but what I'm going to do is I'm going to label every other one. I'm still going to go by 5s, but I'm going to label every other one. So I have 0, and then I'm going to skip 1 and come down here to this one and name it 10. Do you see what I'm saying? So it's still by 5s, but I'm only labeling every other one so that it looks neater. So that's 40. We got 50. mine fills up my graph because I have a little bit different graph paper on my notes than what you do. Yours is a little blurry, and I apologize for that. It's not the best graph. So I traded them out so that you guys could see this a little bit better. So that's how we scale the time. Now we need to figure out what we want to do with miles. Miles goes from 5 all the way up to 22. What do you think the best way to go about that is? Twos is what we've been doing. Well, we could probably fit ones on there, but 2 works also. And obviously, either one would be fine. I'm going to go ahead and do by 2s, though. So this is 2. We got 4. So go ahead and label this all the way up to 22, because that's as high as we need to go here. So you go ahead and get your scale. Figure out your scale, then label your axes. And then we have to plot our points. To plot our points, remember time is x, miles is y. So my first coordinate point is going to be 27, 5. Okay, that's going to be my first coordinate point because this right here, those 2 points go together. So I'm going to come over to my graph and I'm going to put the point 27, 5 on my graph. So I want you to go through that and do that next. Get all your points on the graph. We got 27 and 5. That right there. Got 4610 is there. 14. Goes about there. And 22, 107, 22. So your graph should look something like this.
Positive correlation.
This does appear to be a positive correlation. Now, once you get the points plotted, you need to go through and you can take a straight edge or something, or you can eyeball it, it's fine. You're going to draw a trend line. We're going to draw a line that fits this data best, all right? So I'm going to try to draw a line here. Mine aren't real straight usually because they're, you know, I don't know, they're just usually not. So I'm going to draw my line the best I can here. Try to make it as straight as I possibly can. Let's see. Go about like that. That's pretty straight. Obviously, I'm not going to draw the same trend line that, say, Kenzie might. Ours are probably going to be different, okay? No 2 people are going to probably have exactly the same trend line. So what I want you to do, because we have to now find the equation of our trend line, but because all of us have so many different looking trend lines, we're going to go ahead and just use my data on my trend line so we're all using the same numbers, because obviously answers will vary here, depending on what line you drew. So we're going to find the equation of my line. Okay, that way you know the steps to finding the equation. You could go back later and find the equation of your line. But I want you to follow the steps with me so that you understand how to do it. So what your first step is going to be is to go through and find 2 points that are on your line that are at nice even intersections, which is just what we did when we did that slope-intercept activity before Christmas. So I'm going to find 2 points that I think are nice even intersections. I'm going to pick this one, looks good to me right here. I'm going to put these 2 in black ink here. There's that point, and then another point on that line. Let me find another one here. Keep going, keep going.
There you
Right
go.
there, right there.
That one right there? That's pretty close. All right. Thank you. So we're going to use those 2 points. Okay, let's write down what those coordinate points are. So the first one looks like it's 48, not 48, but 40, comma 8. And then the other point is, let's see, what is that? 65, 14. So those are my 2 coordinate points I'm going to use. I need to find the slope. Now, because we've got the line on the graph, we can count the rise over the run. We can use the slope formula, and that would work just fine. But we can count our rise over our run from one point to the other. So I'm going to do that. If we have to rise, how many? I rose 3 units, but every 1 unit represents how many? 2. So I'm really going rise how many? 6. And then I'm going to run 1, 2, 3, 4, 5 units. Well, each one's worth 5 though. So 5 times 5, that's 25. So my slope then, my M, is rise over run, which is 6 over 25. So this right here is my slope. And then I need to use just 1 point. And then I have a point and I have a slope, and I can put it into the point slope formula, which is what we've been doing time and time again. So we have this M. We'll call the 40, comma 8, we'll call that one x1, y1. So now we're ready to write our equation like we've been doing. We write it in the slope or point slope, which is y minus y1 equals m parentheses x minus x1. So then we plug in the necessary numbers here. This, we don't really need this coordinate point anymore. So we do y minus y1, which is 8, equals m, which is 6 over 25, parentheses, x minus x1, which is 40. So this right here is our equation. So that's the first part of that question, basically. We do the scatter plot, we draw the line of best fit, we find the equation for it. But then there was another part to that question. If you go back up there, it wants to know, just scroll back up here, it wants to know, use the equation to predict the time needed to travel 32 miles. So we need to figure out how to do that. We're going to use our equation. So what I'm going to do is I'm going to clear some space. I'm going to rewrite this equation to where it's easier to work with. Okay, so that's what we're going to do next. So let me clear my ink here and leave some space. Somebody might need to read that equation to me again.
Y minus 8
Thank you.
equals 6 over 25, x minus 40.
All right. Thank you. All right. What we want to do is we want to go ahead and get this equation into a little bit easier of a format. Now, because this is an estimation of a trend line, and it's not really an exact answer, I'm going to go ahead and let this 6 over 25 turn into a decimal if you want. Okay, so we're going to go ahead and figure out what 6 divided by 25 is, and we're going to turn it into a decimal first. Normally we wouldn't do this, but it's a trend line, so it's already something that we're kind of approximating anyway. So we need to go ahead and take 6 divided by 25. Can someone do that for me? Anybody?
4.1.
Well, that's not it.
Oh, darn it, I wrote it.
0.24. Okay. 0.24 parentheses x minus 40. All right. So then the easiest way to work with this equation is to get it out of point slope form. Point slope form is not really manageable, but slope intercept form is very manageable. So we're going to go ahead and turn this into a slope intercept. Do you remember what the steps are to doing that? How do I get this into y equals mx plus b form? Distributive property first, yep. So we get y minus 8 equals 0.24x, because 0.24 times x is 0.24x, and then we need 0.24 times negative 40. Well, that's not right. 9.6? Alright, so now, oh, and then one more step. One more step. Add 8 to both sides. That's the last step here. Add 8 to both sides. So we're going to get y equals 0.24x. No, one's negative, one's positive. Negative 1.6. Negative 1.6. All right. So now it's in an easier format. We can work with this. It's much easier. If we want to predict how many minutes it will take to go 32 miles, y represented our miles, x represented our time. So where would I put 32 miles in to get a time? For the x or the y, where would I plug it in? If I'm plugging in miles, which one was miles, x or y? Y. So I'm going to put 32 in for y to predict how many miles. And then we're going to use this tomorrow. This is kind of what we're going to do tomorrow. So we're going to plug in for y, we're going to plug in 32. So we get 32 equals 0.24x minus 1.6. So we solved this equation. This now becomes a two-step equation where we want to get x by itself. So now what we're going to do, so we want to get 0.24x by itself. So we're going to add 1.6 to both sides. So we get 32 plus 1.6, we get 33.6 equals 0.24x. One more step, we're going to divide 0.24. What's 33.6 divided by 0.24? Wouldn't it be awesome if I assigned you calculators that you could use? Yeah. Oh, wait, I think I do that already. Divided by 0.24. So 140. So x is 140. So that means we would need about 140 minutes. And this is approximately. Some of you would get a different answer depending on your trend line. Tomorrow our x and our y will be, our x will be the number of rubber bands we tie to the feet of Barbie. The y will be how far does she fall each time. And we're going to add a rubber band each time. We're going to make a scatter plot. We're going to predict how many rubber bands it's going to take for her to safely jump off of that shelf up there up at the top. And if your trend line is good and you've done all your math right, Barbie should have a safe bungee ride. Okay? If you approximate incorrectly,
She did.
bye-bye Barbie. So that's what we will be doing tomorrow. So you guys, it's important that you practice this tonight. I have some homework for you.